Okay, hi guys. So in the last lecture, we saw that delta S would be equals to n CVM plus R ln T2 upon T1 plus nR ln P1 upon P2. So just continuing from that. So let's say we have a constant temperature. So at constant temperature, this term would be equals to 0. Okay. So only term left would be nR ln P1 upon P2. So if the pressure decreases, then entropy would increase, or the volume increases, then also entropy would increase, as delta S now can be written as nR ln P1 upon P2. What happens at constant volume or pressure? So at constant volume or pressure, this term would be 0. The only term would be remaining is n CVM plus R. CVM plus R, I am writing CPM ln T2 upon T1. So if temperature increases, entropy also increases. Now let's see what happens in case of isothermal ideal gas expansion and compression. We have a reverse, first say let's have a reversible ideal gas expansion as a process. So delta S system can be written as delta S equals to Q reversible by T, and as we have isothermal, so we can write that Q reversible would be equals to nr nRT dV. Okay, nr upon nRT upon VdV rather. So just integrating that, so we'll be getting T and T getting cancelled out there, and we will be getting something like minus PdV would be minus nRT upon V. This is P and dV. Okay, so this would be Q, and Q by T, this would be dQ rather. dQ by T would be something like this. So dQ by T would be nothing but ds. So ds would be nR dV upon V. Just integrating that, so it would be nR ln V2 upon V1. Okay, and delta S surrounding would be, as for the reversible ideal gas expansion, delta S total should be 0. No change in entropy would be there. So delta S system would be equals to negative of delta S surrounding. So delta S would be negative of minus nR ln V2 upon V1. Now let's say what happens in case of irreversible ideal gas expansion. So in case of irreversible ideal gas expansion, delta S can be simply written as nR ln V2 upon V1. Okay, so and delta S surrounding would be 0. Okay, so this is irreversible ideal gas expansion. So let's say this is free expansion, where P external would be 0. Okay, so now as P external is equals to 0, so delta S system can be written as nR ln V2 upon V1. Okay, because expansion is still there, and work done would still be minus PdV, and P can be written as nRT upon V. This is P. PdV would be something like this. So this would be minus of Q, because W plus Q equals to 0. So Q would be equals to minus W. So Q would be something like plus of this, and delta S would be equals to this Q, because this is a free expansion. So this Q by T, or dQ by T, can be written as, by T and T get cancelled, again delta S can be written as nR ln V2 upon V1, and delta S surrounding would be equals to 0, because that would be equals to, again Q plus W would be equals to 0, and here W would be taken P external times V2 minus V1. P external is 0, hence Q would also be 0. So delta S surrounding would be 0, hence total S total would be system plus surrounding, that would be equals to greater than 0. Next we see the irreversible ideal gas expansion against some pressure. So now we are applying some P external, so the delta S system would still remain the same, but the for the surrounding we can write that for the surrounding, whatever heat is generated from the system to the surrounding, heat generated from the system would be Q irreversible, and heat that is imparted to the surrounding would be minus of this, because heat is going from system to surrounding. So Q irreversible can be written as W irreversible minus of Q irreversible rather can be written as W of irreversible by T. Okay, and W of irreversible can be written as minus P external times dV, or simply minus P external times V2 minus V1. This would be W irreversible. Okay, and the summation of both, which is delta S of system plus delta S of surrounding, would be greater than 0. Okay, because we know that W reversible is greater than W irreversible. Okay, so here, as V2 would be more than V1, so this would be a positive term and this would be a negative term, because this is minus P external V2 minus V1. V2 minus V1 is a positive quantity and P external is also a positive quantity, but we have a negative sign against P external or ahead of P external, so we have a negative quantity here, and the summation of both, which is positive here and negative here, would still be positive. Okay, so just writing some notes here, that initial state we are considering as P1 V1 T1, and final state we are considering as P2 V2 and T2. And as S is a state function, we can write delta S as equals to SF minus SI. And similarly, some points here, that dq reversible by T is not equals to dq irreversible by T, and W irreversible is, as we just discussed some few minutes back or few seconds back, that it is minus P external times V2 minus V1. So we can write that delta S total can be written as, for the last case where we were seeing irreversible idle gas expansion against some pressure, so we can write this would be equals to delta S system plus delta S surrounding. Delta S system can be written as, this is nothing but W reversible, but with the negative sign, because W irreversible, or rather W reversible, is a negative quantity because it is minus P dV, and dV is positive, hence W irreversible is a negative quantity, so we can write it would be nothing but W minus of W reversible minus W of reversible by T, and system delta S of surrounding would be, here again delta S of surrounding we already know, we have derived it as W irreversible by T. Please note that this would be a positive quantity and this would be a negative quantity, because in both the cases expansion is involved, and the sign of W would be just the opposite of the sign of dV. So dV is, if dV is positive in case of expansion, W would be negative, and as W is negative, this term would be positive, and we already know that mod of W reversible is greater than W irreversible, so minus of W of reversible would be a positive quantity and this would be a negative quantity, and still the sum would be a positive quantity. Okay, I hope you are getting this. So we can write this as minus W reversible plus W irreversible by T would be greater than 0. This is delta S total. Okay, in case of irreversible idle gas expansion. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing adiabatic idle gas expansion or compression. So till then, good luck and goodbye.